1. The question says a 10-gram mass placed on the pan of a spring balance causes an extension of 5 meters. If a 15-gram mass is placed on the pan of the same spring balance, calculate the extension. Or what will be the extension? If you look at the parameters given to us, we are given a particular mass. We place that mass, which is 10 grams, on the pan of a spring balance, and that mass causes an extension of 5 meters. Okay? In this case, instead of dealing with force, we are dealing with mass. Okay? We have mass, let's call it M1, which is equal to 10 grams. And this one causes an extension, let's call it E1, 5 centimeters. Then we are now told that if instead of having 10 grams, we now place 15 grams, call it M2, on the same pan, what will be the extension produced? Call it E2. We are looking for E2. Let's come from Hooke's law. We have K is equal to force over extension. Okay? Then from this relation, you can come and say F1 over E1 will be equal to F2 over E2. I have told you we are dealing with mass, even though what we are having here is force. We are still going to take our force as mass in this case. Okay? So, for our F1, which you are going to take M1 in place of it, it will be 10 divided by 5 will be equal to our F2 will be taken for M2, 15 divided by E2, and that's what we are looking for. We are going to have 10 times E2, 5 times 15, E2 will be equal to 5 times 15 divided by 10. And E2 will be equal to 5 here 1, 5 here 2, 15 divided by 2, which is equal to 7.5 centimeters. And that will be the extension produced if we are to place 15 gram mass on that same pan of the spring balance. And that's the simple solution. Question number 2. The total length of a spring when a mass of 20 kg is hung from its end is 14 centimeters, while its total length is 16 centimeters when a mass of 30 kg is hung from the same end. Calculate the unstretched length of the spring, assuming Hooke's law is obeyed. This is going to be let unstretched length be held. The unstretched length. Instead of using the word unstretched, you can also use the word the original length, the initial length, the unstretched length. Let it be held. So what will now be the extension produced by the time we have a mass of 20 grams hung on the spring balance, hung on the spring balance. The extension produced, let's say for the 20 kilogram mass, the extension will be, let's call it E1, equal to final length, okay? And the final length we are having there, the total length, or the final length is 40 centimeters. It's going to be 14 minus unstretched length. For the 30 kilogram mass, extension will be, let's call it E2. We are given the total length, and the total length is 16. It's going to be 16 minus L. That is the approach to this question. From Hooke's law, F is equal to KE, and our K is F over E. Can you see that? In this case, we are dealing with force, even though we are given in kilogram. Okay, we are going to take the kilogram we are given, we are going to multiply it by 10. This is going to MA or MG. Okay, which is going to be F1 over E1 will be equal to F2 over E2. That is what we are having here. Okay, for F1, that is our first mass, is going to be 20 times 10. Where do we see this 10? This 10, where we have F is equal to mg, which is the same thing as F. We are taking our weight and our force as the same thing here. Multiply your mass by 10. Divided by E1. Your E1 is 14 minus L. Your F2, you are going to have 30 times 10. Your E2, 16 minus L. From there, if we try to evaluate it, this is 200. You are having 14. This is 300. You are still having 16. Try to cross multiply. When you cross multiply, what are you going to have? 200 into 16 minus L. 300 into 14 minus L. When you try to multiply what you are having out, let's see what you are having here. We have 200 times 16, and that will give us 3,200. 3,200, that's that, minus 200 L. All what I'm doing is open the bracket. I'm opening this bracket. Then, let's see what will be the value of 300 times 14, and that is 4,200 minus 300 L. Let's take the like term. Minus 200 L plus this minus will become plus. 300 L, 4,200 minus 3,200, and this one will give us 100 L. It will be equal to, and you subtract 3,002 from 4,002. We are going to have 1,000. So that L will be equal to 1,000 divided by 100. And if you try to count, we have 10 centimeter. 10 centimeter. Question number 3. A force of 100 Newton stretches an elastic string to a total length of 20 centimeter. If an additional force of 100 Newton stretches the string 25 centimeter further, find the natural length of the string. Let's look at the question critically. We have a force of 100 Newton. We apply that force on an elastic strings, 100 Newton. It now produces an extension, a total length of 20 centimeter, and that is a final length. Okay? Then we now put another force of 200 Newton, stretches the length, and then also stretches, instead of having 20 centimeter, you now have 25 centimeter. What will be the natural length of the string? We should let our natural length be L. Then if you look at the question we have here, we are told that a force of 100 Newton now stretches that elastic string to a total length of 20 centimeter. We are going to say for a stretching force of 100 Newton, the extension produced equal to extension E will be equal to the final length, which is the total length, minus natural length. And the total length in this case is we are given 20 centimeter. 20 minus L. Take care of that. You can call it E1. For a stretching force of 200 Newton, the extension, call it E2. We are also given the total length for that, and the total length is 25 centimeter. We are told that an additional force of 200 Newton hang on it. So for 200 Newton, for a stretching force of 200 Newton, then instead of having 20 centimeter, it now turns to 25 centimeter for 200 Newton. So we are going to have 20 minus L plus 5. That is the additional 5 that adds to the extension. Okay? So our E2 will now become 25 minus L. Okay? So from Hooke's law, F is equal to KE, K is equal to F over E. Okay? Then we can come on and say F1, E1, F2, E2. What is going to be our F1? We have been given for the stretching force of 100. 100. Our extension E1 is 20. That's 20 minus L. For F2, additional force 200. We are going to have for extension, it's going to be 25 minus L. So if you are to solve this mathematically, rather, we are going to have 100 into 25 minus